Right, students, good evening. Students who are in the online, am I audible? Aniket, I check that. I'll check once. If it is not uploaded yesterday, I'll upload it. Okay. So now let's move to the further. I hope today the most important topic, inheritance, I'll explain it. So inheritance in Python. Inheritance in Python. Okay, come in. So now I'll move to the further discussion, students. Carefully follow me. What is the significance of this inheritance in Python? We'll discuss one by one now. So here, let me open once. Whoops, index. Instead of putting that index once again in the inheritance, I'll show you that. Index of oops. There we have all these things discussed perfectly. We are in the discussion of one by one. Now we are in this facility. Classes and object complete. And now we are entering into where? Inheritance. This part we are discussing today. Actually, inheritance and polymorphism are combined together. Like classes and objects, how together we discussed. How discuss this encapsulation and abstraction. Inheritance and polymorphism are something like a interrelated. Today we will discuss inheritance. Later we will add polymorphism to the inheritance. So separately, first I will discuss this inheritance topic. What is an advantage of this inheritance topic? I will discuss. Why inheritance concept is required. Which you have completed already. What are the reusable techniques which we learned it? What are the reusable techniques we learned in the class? Come on. Come on. Huh? What is that? Code? Code reusability techniques are what? Functions, modules, good, very good. Packages. Function will do what? Reusing in the same. Not possible to reuse across the programs. Modules are used to reuse the code of the functions across the programs, provided they present in same folder, but not possible to reuse across the folders. To reuse the code across the folders, across the environments, across the networks, will go for what? Packages. This is what we discussed already in functional programming in our previous discussion. Today, I am going to ask you in whoops, how the reusability to be done. In whoops, reusability I am going to talk. Take an example. Every whoops program, every object-oriented program must start with what? Class. Compulsory must start with a class. What is the class name? Class. Name of the class is OTP. For example, OTP. For example, you take it. Inside the class, I will take up def generate OTP. Generate OTP of self. Look at students. I am writing by using random module. You know random module already, right? Yes. Using random module, and you will apply a lot of things on it, and you will be writing this code. And you know, here I think so, students. You will write multiple lines of code. Come in. You will write multiple lines of code. Assume that I wrote almost 5 to 6 lines of code I written. Assume that some 5 lines of code is written and I thought of writing 5 lines of code and I'm writing something like, 5 minutes of time is spent. There's a time and a number of lines. This code is useful to some students want to use this. One first student, Monica want to use, Sagatika want to use, Prajwala want to use, and next is called what, Sri Lakshmi want to use. Like that, multiple students want to use it. Multiple students want to use it. Monica want to use, Sagatika want to use, Prajwala want to use, and next Sri Lakshmi want to use it. Think about it. So programmer name is called class Monica. For example, Monica. One more kind of class I say. One more kind of class. So I'm writing here called what, something like so, like this. One more student here. What the another student is called what, so like this. And one more student I am writing here. One more student I am writing something like, like this I wrote it. Here, all these people need what? Generating OTP. What are the project? So far, what? Class objective, encapsulation, abstraction. What he will do? The OTP code is already defined by programmer called KVR. Is a programmer, he has defined already this code. What these programmers has to do? They need to define same code again. Usable technique. They are writing the same code again. Here also they are writing the code again. They are also writing. Sagatika also writing the code. Monica also written the code. Monica also written the code. Now see students. Monica also written the code. Prajwala also writing the code. Now Sri Lakshmi also written the code. Now think about it now. They are writing the same code again and again, again and again, again and again. Why? In OOPS, they don't know how to reuse the function of one class into where? Another class. One class into another class. They don't know how to reuse. In functions, reusing across the programs we know. Reusing across the module, across the folders you know. But one class to another class I want. What is the concept? Modules no, packages no. Here function only reusability. But what to what? One class to another class I want. To get the function definition from one class into another class, I have to use the concept of what? Inheritance. Suppose if we don't know what? Inheritance. What they need to write? 5 lines of code, 5 minutes of time. 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 For one task, written the logic again and again or not? What time it will take? More amount of time is taken. Is it not a waste of time? How can we avoid this problem? By using inheritance. What inheritance is? Inheritance is when you want to get data members, methods of what? One class into where? Another class. If you want to get the same code, same data members from one class into another class, apply which concept? Inheritance. What is the definition of inheritance? The process of obtaining the data members and methods from one class into another class. Not only data members and methods, constructors also. Java will not participate in constructors, will not participate in inheritance. But in Python, participates constructors. Constructors participates in inheritance. So what is the definition of inheritance? Tell me. The process of obtaining the data members, methods, constructors from one class into another class is called inheritance. So tell me, Monica programmer, Sagatika, Prajwala, Sri Lakshmi, these programmers, is it necessary to write the same code again and again? Now what they will do? Reuse the function from one class into, reuse the data member from one class into another class. Because of that time, what is happening? What is the advantage? Number one, development time is less. Space is less. Execution time is very fast. Redundancy of the code will reduce like anything and performance will increase. These are the advantages of inheritance. In OOPS level, reusability is what concept? Inheritance. What is the definition of inheritance? The process of getting the data members from methods and constructor. These three things. Destructor will not inherit. Destructor will not inherit. Constructor, methods, data members will inherit from one class into the class which is giving the data members and methods is known as what? Base class, or we can call it as a super class, or we can call it as a parent class. Parent class. Are you following? The classes which they are getting the data members from base class or super class is called derived class or subclass. Derived. We can also call it as a sub, also called as a child class. Are you getting or not? Now, tell me, will they write the same code again and again or not writing? Not at all writing. They are not wasting their time. They are not taking the memory space for everything. But how the memory space, sir? Whatever the code is written, the same thing will be coming here. But here, neither takes the memory space, nor you are writing the code for that. That is nothing but available virtually. Available what? Virtuality. What is meant by virtuality? We feel that it is there, but in reality, it doesn't take memory space. For example, in our class, Saturday, 187 students are there. Daily around 225, 230 people will be there. All of them are under UGC, underground action plans they are executing. So, these many are absent. So, 188 people, are they really sitting in my class? No, but they are in the class. That is called which class they are attending? Virtual class. You are sitting here physically and your strength plus that strength will become total class. So here, whatever I am getting from here to here, this is getting as it is, but that is not taking any memory space. Neither we write the source code for that, nor taking the physical memory space. We call it as which memory management? Virtual memory management. Spell out now. Virtual memory management. Somebody will call it as what also? Logical memory management we can call. Logical memory management. Physical memory management. Logical memory management. Physical memory management means what? Takes the memory space physically. Logical memory management means what? We feel that it is there, but in reality, it won't take any memory space. That is known as what memory management? Logical memory management. Is it understandable? So, inheritance follows which memory management? A logical memory management. Take Windows operating system. Take Windows operating system. Windows DOS, Windows 95, Windows 98, Windows NT, Windows XP. Like that, Windows 7, Windows 8, Windows 9, Windows 10, Windows 11. These are all getting the previous features into current one or not. What is this facility called? Inheritance. Mobile development, you take it, Samsung mobiles, OnePlus, Oppo, Vivo. Do you take this mobile modeling, remodels are coming? That modeling, new models are coming, carrying the previous model features or not? What these are all called? Inheritance. Did you understand inheritance? So what is the purpose of inheritance? To build reusable applications in OOPS. To build reusable applications in OOPS, we'll go for which concept? Inheritance. Abstraction says what? Retrieving the essential details without considering the hidden details. Encapsulation says what? Hide the confidential details. Class, designing the programmer defined data type for customized data storage, for customized operations to perform. Object required to store the data. Inheritance required to build the reusable applications. Getting up? So now I am going to conclude my sentences. Inheritance definition, inheritance base class, derived class, super class, subclass, parent class, child class. These are all similar terminology, no? Advantages of inheritance also you understand. Shall I show you one documentation? A small documentation I will show you, students. And please follow me under whoops here. I'll bring the notes. Only notes I will bring it because I want to utilize this time. Here I am going to take it. Under whoops, students, please follow me. I'll create one small folder here. I'll say here inheritance. Under that, I will take up. I will show you the introduction to inheritance here, students. Just follow me. Because first I am covering the concept clarity. Inheritance is one of the distinct feature of whoops. The purpose of inheritance is that to build reusable applications in Python object-oriented programming. Definition of inheritance. The process of obtaining the data members, methods, constructor. These three things are called what? Features of one class into another class is called inheritance. The class which is giving the data members, methods, and constructors, that is the features, is called super or base or parent class. The class which is taking data members, methods, and constructors is called sub or derived or child class. The inheritance concept always follows logical or virtual memory management. This memory management says that neither we write the source code nor takes physical memory space. But as it is coming from somebody's code in my place, neither I write nor takes physical memory space. Advantages of what? Inheritance. When we develop any inheritance-based application, we get the following advantages. Number one, application development time is less. Why application development time is less? Somebody has written the code. I'm getting the code as it is. I don't spend much of the time. Reusability. Application memory space is less because I'm not writing now. Definitely it won't take the memory space. Application execution time is fast. No space taking, fastest execution. Application performance is more. Less space and less execution time. More performance. And the redundancy of the code is minimized like anything. Because if I change the code one time, it is reflecting on all the places whoever is reusing. Correct or not? So these are the advantages of what? Inheritance. So whoops level reusability is what? Inheritance. Functional level reusability is functions, modules, packages. Got it up? Now, sir, how many ways are there to inherit the things? Let us start discussing. Now I am talking about types of inheritances. I am trying to give you types of inheritances. Before going to the topics, programming, I want to cover this part. Types of inheritances. Types of inheritances I want to talk. How do you do this now? First one I am talking about it. First one I am talking. Please look into that. I am not writing the complete diagram because in the color diagrams I'll show you, but I'm drawing on the screen. Suppose you are a parent and a child. Parent and child is always which concept? Inheritance. Somebody will say you are looking like your parents, but your parent is reading very well and you are not reading at all. That is also property, yeah? No. So leave it that. Parent is giving the total properties to the child. This is called which class? Base class. This is called which class? This is called single inheritance we can call. Spell out. So type of inheritance is one type of model, student. Type of inheritance is one type of model. Or it is called one type of diagram. It is called one type of diagram. Or it is called one type of pattern. It is called one type of pattern, which makes us to understand how the features are inherited from base class to derived class. Features means what I told, data members, methods, and then constructor. How they are inherited from base class to derived class. I am showing that. Getting my point? This is called which inheritance? What is the type of inheritance? It is a model or diagram or pattern which makes us to understand how the features are coming from base class to derived class. Got it up? Well, next class, next inheritance. See, your grandparent, your parent is a son of grandparent, right? Parent, and you are the one, and you are the one. What is GP? Base class. What is parent? Derived class. And if I think these two, okay? Now, you think these two. What is derived class here? Parent base class. What is this C? This is known as multi-level inheritance. Multi-level inheritance. What is multi-level inheritance? In multi-level inheritance, there is a base class, single base class. There is a single derived class. There is a intermediate base classes will present. 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 A class which is acting as a derived class come base class is called what? Intermediate base class. Are you getting me? What is an intermediate base class? In one point of time acting as a derived class, in another point of time acting as a base class is known as what? Intermediate base class. Did you understand? What is this inheritance is known as? Multi-level. Got it down. Next, one more. Suppose you take it, one more type of inheritance. And KVR is a class, is a teacher here. And under that, there is a student 1, student 2, so on. Number of students are available. Number of students are available. Here I am writing yes, 202 students. And slowly they are coming. So 6 o'clock now, they went to the sleep at 4 o'clock, going on sleeping. Slowly alarm is coming out. Actually, alarm kept at 5:45 only. First time alarm coming, not snoozing, stop it. Next 10 minutes, once again it is ringing. Again, by the time what is happening? 5:45, 10 minutes, 5:55. Again ringing. Almost 5:10. Again, 5:20. All of a sudden, okay, log in. That is a strength. 204 students. 2:30, 6:30 also they will come. And they are deep sleep, that is. After the class is over, again going to sleep. Different. I know your all accents because I have seen everything. And don't ask, sir, you also slept like that. So I'm little different, students. I'm little different. That's why I'm standing in front of you today. Okay, anyhow, students, is that class, base class, and these are all called what? Derived classes. Derived classes. Monica? Okay. Snacks time for kids. Okay. Good. So S1, S2, S3, so on, S202. Right? 207 now. See, within 5 minutes, how many are increasing? 5:30. 6:30, you see how many will come out. So these are all alarm batch that is called. Now, 207, now 208. These are all called what? Derived classes. This is called a base class. How many base classes? One base class. Multiple derived classes these are. Multiple derived classes these are. This is called what inheritance? Hierarchical inheritance. Hierarchical inheritance. Lot of people will think that multiple inheritance. Wrong answer. This is a hierarchy. A teacher and students. A boss in your office and a number of employees in the company. They are all called what? Hierarchical inheritance. How many inheritances? How many I said so far? Number 1, 3. Number 1, single inheritance, multi-level, hierarchical. You remember the diagrams also? Okay, reverse. Now see, your LKG teachers, I am taking your knowledge power. And your upper primary school teachers, and your school teachers, and your intermediate teachers, 10+2 teachers, your BTech teachers, and their super knowledge is coming to student. That is the student today. So see how many students, how many teachers knowledge is coming. So you are superpower. Are you superpower? Huh? Are you superpower? Yes, sir. Who is that? Yes, sir. You are? You are? Who said superpower? Okay. Stand up. Yes. How many alphabets? Everybody, how many alphabets? 26. 52 are there. Everybody watching 52. I'll tell you. Sit down. 52. I'll tell you. Don't, when I'm saying something, there is a more meaning. Now I will come to. Let me finish this. Tell me. At 52 means don't tell to kids 52. You tell to kids 26 only. When you go to any bigger company, how many alphabets are there? 52 you tell. This is my advice. If you say 26, person like me will say left and right. How? I'll show you. What these classes are? This is the question in PayPal. This is a question in PayPal. Everybody will tell 26 only. No doubt in that. Even I am there, I will tell that. But practically, I'll show you. These are all called base classes or not? Yes, base classes. And this is called what? Derived class. This is called which inheritance? Multiple inheritance. Multiple inheritance is containing multiple base classes and what? Single derived class. That is known as which inheritance? Multiple inheritance. Got it? Now, go to Python environment. I want to convince you. Go to Python environment. So already some students got it. Sureka got it, that answer. ORD of capital A. I'm going to how 52. Capital A. Starting letter ASCII code is 65. Small a is 97. How many varieties of alphabets? Uppercase alphabets, lowercase alphabets. Are they same? Are they same? How many uppercase? 26. Lowercase. Are they same? How many? That's it. And don't ask me, sir, curly alphabets are also there. Can you write curly alphabets here? No. You cannot. That's why alphabets are how many? If anybody says 26, open your laptop and show this answer. If they don't know technology, we don't do anything. Correct or not? So, right, ma'am, Sureka, correct. So everything is more technically you need to satisfy. How many inheritances we discussed? 4. Next I am going to last hybrid inheritance I am explaining. Look at hybrid inheritance. See students, this is called C1, my dear students. C2, this is C2. What this is called? Single inheritance. And from there, I say C3 and I say C4 and I say C4. See the combination. What is this? This one is called single. What is the below one? Hierarchical. Single. Are you following? Good. Next, you see another combination in the same. This is called what? One type of combination. What is this? Multi-level. This is called another combination. What is this? Multi-level. So 2 multi-levels are called what? Hybrid only. One more. C1, C2. What is next? C3. What is this is called? Hierarchical. And below one you see. Below one you observe it. What is this is called? C4. What is the above one? Come on. What is the below one? Multiple. How many combinations? So it is looking like a rhombus or not? Some interviewers are asking, what is a rhombus? It is nothing but hybrid inheritance only. Diamond also, some people will call it as a diamond. What is the diamond kind of thing? It is nothing but what? Hierarchical plus multiple. This type of thing is known as hybrid inheritance. What is the hybrid inheritance? Combination of available inheritance types is called what? Hybrid inheritance. How many inheritance types? 5. What are those? Spell out. Single, multi-level, hierarchical, multiple, hybrid. Do you know the diagrams also? Right. My dear students, online students, did you understand, students? Now I am showing types of inheritances. See, students, because I want to concentrate more on coding, because same thing typing waste of time. A type of inheritance is a model or paradigm which makes us to understand how the features are inherited from base class into derived class. In Python programming, we have 5 types of inheritances. They are single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, hybrid inheritance. Okay. Now, dear students, I am going to introduce, I will show you a colorful definitions to you. Look at. And to draw this entire thing, it takes some time, because if I make it one time now, it will be continued for all the batches. Single inheritance definition. This inheritance contains single base class, single derived class. Diagram. C1 is what class? C2 is which class? What is this inheritance is? Single inheritance. Next is called what? Multi-level inheritance. What is this now? This inheritance contains single base class, single derived class, and intermediate base classes. C1 superclass, C2 subclass or superclass, C3 subclass. C1 is what class? Superclass. C2 is acting as a subclass, and which is acting as what? It's not only one student. C2 you take it. C3 you take it. No issue. C4 you take it. C4. C4 is a derived. C1 is a super. And C2, C3 is what? Intermediate. Intermediate. Okay. Hierarchical inheritance you take it. Hierarchical inheritance you take it. What is the hierarchical inheritance? This inheritance contains single superclass and multiple subclasses. C1 is what class? And C2, C3, Cn are what? Subclasses. Are able to follow? Now, C1 is a superclass. C2, C3, Cn are what? Subclasses. Are you following me? Good. Coming to the point back. Now I am going to say 3 types of inheritances. Let me go for it. And multiple and hybrid inheritance. So here I am going to take up, observe it, multiple inheritance. This inheritance contains multiple superclasses and a single subclass. Multiple superclasses, single subclass. What inheritance? Multiple inheritance. Hybrid inheritance I am going to take up. See the hybrid. Read the definition, guys. Hybrid inheritance is equal to combination of any available inheritance types. Diagram 1, diagram 2. C1 to C2, C2 to C3, C2 to C4. Single, and next is what? Hierarchical. Diagram 2, C1 to C2, C1 to C3. It is called what? Hierarchical. Below one is called what? Multiple. These two are comes under which inheritance? Hybrid. Got it up? So, what did you understand about inheritance? It is used to build the reusable applications. Advantages: memory management. What memory management it follows? Virtual memory management. Logical memory management. Advantages, you know. Types of inheritances, you know. How many types? 5. Now I want to tell you syntax. Sleeping. T-shirt. White T-shirt, black T-shirt combination. Yes. Sleeping. No? Stand up. Second time I am seeing that. I don't know whether I'm correct or not, but I'll check it once. What is the definition of hybrid inheritance? Don't see on the screen. I'm not asking you. Ma? Combination. At the you are already matured student. You would explain like anything. See on the screen. Read out. Combination of available. Combination of any available inheritance types is called what? Hybrid. What is the multi-level, you tell me? Multi-level inheritance time also I looked at you. What is the multi-level inheritance? Tell me. Small snap is taking and again wake up. Correct? No? Maybe wrong I am, but I am asking this. I looked at that time. I did not see you when you are in open eyes. Multi-level. Not remembering? C1, C2, C3, C1, base class, C3, derived class, C2. Intermediate anaguddu. Intermediate is 10th class, 11th or 12th class. Intermediate base class. Paluko sare? Mela palakali. Intermediate combination atla anagudumma. Complete cheppali. Okay na? Sit down. So now I am going to introduce continuation of this subject. Now I'll go to the subject of, after understanding this entire thing, I'll tell you the syntax now. For what purpose? What I am going to discuss now? Syntax for inheriting the features of what? Base class into where? Derived class. Syntax for inheriting the features of which class? Inheriting the features of which class? Base class into which class? Derived class. Syntax for inheriting the features of base class into which class? Derived class. I'm going to discuss. Very, very easy. How it is simple? Now I'm going to discuss. To inherit the features of, which class? Base class into which class? Derived class. We use the following syntax. We use the following syntax. What is it? Class, take care students, CLS name 1. Now I am saying something is present there, which is defined by somebody. I am taking one more kind of class, C2, class name 2. I am writing class name 2, writing here. Class name 2 want to get the data members and methods of constructors of which class? Class name 1 to which class? Class name 2. The time I have to write inside the tuple bracket, I will write what? CLS name. CLS name 1, I will write it. Class name 2, class name 1, colon. I just wrote like this. You got my point? Class name 2, getting the data members and methods of which class? Class name 1. So class name 1 features are available in where? Class name 2. So class name 2 contains how many varieties of features? 2 varieties. One is class name 1 varieties features virtually, plus physically what are present? Class name 2. Your parent got having money and you have the money. Your parent money is available logically with you and you have the physical money with you, and 2 varieties of properties are there with you. Are you getting me? Right. If you don't write it, for example, one more class and I will write it. One more class I will write it. One more class n I will write it. See students, now I am writing class n plus 1, I'll write it. Class n plus 1, here I am writing CLS name 1, comma, CLS name 2, CLS name 2, so on, CLS name n plus 1, CLS name n. All these classes are coming to where? All these classes are coming to where? N plus 1. N plus 1. So n plus 1 is receiving this class, this class, this class. Everything is coming. And so much of discussion will be there in the class. Coming to the explanation now. What did you understand about this explanation? Carefully follow. Everybody tell me. What is the class name n plus 1? Don't take much time. Here, CLS name n plus 1 is called which class? Okay. Class name 1, class name 2, class name n are called what? Come on. Are called base classes. Are called base classes. Okay. Now, what is this diagram says? Here, the features of, I'll write here the features of class name 1, class name n are inherited into class name n plus 1. Class name what? N plus 1. And they are available virtually or available what? Logically. I hope you are understanding. They are available virtually or logically. Good. Now see students, one important point I want to tell you here. How can I access that virtual features? Same thing with respect to the object of class name n plus 1 only. With respect to the class name, if it is instance things, I'll accept with respect to object. If it is a class level, I will accept with respect to class level. If it is a static method, I will access with respect to class name. Everything I can access in general with respect to object name, I can access. Correct or not? Now, overall together, if you really follow me, see students, one important diagram, you please take care. Everybody seriously think about it. This is A. And next is called what you know? This is B. C2. Here B is there. Okay. Here one more I will take it is C3. C3. Here I am writing what you know C is there. Now I'll write the code here. Class C1 pass. Something I'll write. Class C2 of C1 colon pass. Next I am writing class C3 of what? C2 colon pass. Are you following me? C1 things are coming to C2, C2 things are coming to C3. That means indirectly, what is there here? A is there, and what is there here? AB is there. Red in color are called what? Logical features. Tell me, if I create O1 is equal to C1 of what you can access and what you cannot access. When I create an object of C1, what you can access and what you cannot access? O1 dot A, possible to access or not? Yes. O1 dot B, not possible. O1 dot C, also not possible. Because O1 contains the knowledge of what only? A. It doesn't contain the special features of C2 and C3. Next, careful. Green color. O2 is equal to what? C2. O2 dot A, possible? Yes, possible. O2 dot B, also possible. O2 dot C, not possible. Next, one more. O3 is equal to what? C3. O3 is equal to C3 of O3 dot A, possible. O3 dot B, possible. O3 dot C, possible. Which is the better to create an object of it? C1 now, C2 now, C3 now? C3. That means if I develop any inheritance based application, it is always recommended to create an object of bottommost derived class, because it inherits the features of intermediate base class. It inherits the features of topmost base class. So who is having more features? Bottommost derived class is having. That's why we'll create an object of always which class? Bottommost derived class. I hope you got it. So it is always recommended. It is always. So I'm writing, students, always recommended to create an object of which class? Bottommost derived class. Bottommost derived class. Bottommost derived class to access all the features of all the features of which class? Base class and what? Yes, intermediate base class. Intermediate base class. I hope you understood. It is always recommended to create an object of bottommost derived class to access all the features of base class and intermediate base class. Got it up? Clarity is there? Now, one more point. Now, very, very important. Careful, all of you. C1, C2, C3, C3. Who is the superclass for C3? Who is the superclass for C3? C3, C2. Who is the superclass for C2? C1. Who is the superclass for C1? Come on. No superclass is available, right or not? But implicitly, there is a superclass is there in Python. For every class in Python, there exists an implicit predefined superclass. For every class in Python, there exists an implicit predefined superclass whose name is object. Whose name is object. Whose name is object. What is the class name? Object. It is a very frequently asked question. Important in NumPy and Pandas. Important in NumPy and Pandas, students. What is object? If anybody asks you tomorrow when you go to an interview, what is an object? You please put a question to interviewer. Interviewer, are you asking object feature called object? Are you asking superclass for all the classes object? And you are getting clarity from the question. If he says oops feature object, you can explain object purpose, object creation, object definition. If they ask class object, you can say it is a superclass for all the classes in Python. Why it is superclass? Because it provides the most important facility. It provides garbage collection facility to all the classes. So garbage collection started from where? Supermost class called what? Object. From there, garbage collection. Already you know garbage collection. From there, garbage collection. Internally, garbage collection, what was there? Destructor was there. That's why you need not write the destructor on your classes. Because destructor coming from where? Topmost base class to every class it is coming. That's why. What is object? Super class for all the classes in Python. Is it explicit or implicit? Implicit. What is an advantage of it? It provides what facility? Garbage collection facility. Important. Understand, students? Suppose they will write a class C1. They will write a class C1 like this. Who is the superclass for C1? Object. Object. You can write happily inside the bracket like this also. You can write happily like this also. But there is no need to write. Just I am saying to you. What is an advantage of having this? Because it provides what facility? Internal garbage collection contains what? Destructor. That is the specialty of it. In Python, what is int? What is int? Class. What is a float? What is a bool? What is a dict? What is a student? What is an employee? Who is a superclass for all the classes in Python? Object. For int also superclass is object. For float also superclass object. For all the data types in Python, who is a super type? Object. All data types in Python are subdata types of what? Object type. Will you understand? So see that, online students. I hope you are understanding the meaning of that. Now I am opening whatever is explained. I'm just showing to you. Syntax 1, class name 2, class name n. See, I just written a clarity here. Same thing only. Class name n minus 1 is called a derived class or subclass. Class name 1, class name 2, class name n are called what? Base or super classes. Here all the features, data members, methods, constructors of base classes, that means these classes, are inherited into derived class, means this one. And the base class features are available logically or virtually in derived class, and they can be accessed with respect to object name of class name. Which class name? Which class name? Derived class name. When we develop any inheritance based application, it is always recommended to create an object of what? Bottommost derived class, because it inherits the features of base class. Intermediate base classes. That's why we'll create an object of what class? Bottommost derived class only will create. For all classes in Python, there exists a predefined super class called object. There exists a predefined super class called object because it provides garbage collection facility to collect unused memory space and improves the performance of Python based applications. In Python, for all the data types, there exists a super type called what? Object. Because the object is a super class for all the data types in Python. Are you understanding? This is about the syntax mechanism. Now I'll go for the coding. So in syntax of inheritance, purpose of inheritance, types of inheritances. Okay, now? Shall I go to the coding? Right. Online students, did you understand, guys? Now I am entering into the coding. Let us go to the, whether you take PyCharm or you take normal, it is your choice. Right? Go to the place. Now I am going to start the coding. Go to the new part and I am going to take small example. I'll go for it. Program for demonstrating inheritance. First example. Okay. Class C1 def display 1 of self. Small example. First data methods I will take. C1 display 1. C1 display 1 of. Next I will write it. One more type of class, C2 def display 2 of self. I am writing there print of taking here display 2. This is called C2 display 2. Got it? Well, and these are separate classes, students. C1 is separate, C2 is separate. C1 is separate and C2 is separate. Okay. Now I am going to take it what now? Main program. See, students, how simple it is. Come on, create what now? Object. Which object I'll create? For example, this is called a non-inheritance program. Non-inheritance. Please observe it. This is demonstrating non-inheritance. Non-inheritance means what? Non-inheritance means what? Classes and objects. Take care. I will create O1 is equal to C1 of. O2 is equal to C2 of. How many objects created? Definitely will take 2 objects, 2 memory spaces now. Definitely. O1 dot what again? Display 1. Do you know, student? Display 1 is also called what? One object. Because it is a function name. Function name is also one object. Function also will take some memory space. Function also will take some memory space. Next, what I will do? O2 dot display 2. Totally, how much memory space is taking? O1, O2, display 1, display 2. And a total what? 4 objects are there in my program. Execute. See, students, non-inheritance example 1.py. Non-inheritance example 1.py. Say here, done. Go to the place, inheritance. I will save my code. Coming to the command prompt. Here you see d:, KVR, Python. Say here, I am taking, what is it? 6 p.m. Oops, here, CD, inheritance. See guys, I'll write it. PY, see students, I got the output. People see the output, that is academics. That is an academics over. C1, C2, C1, C2, like this. Got the output. That is an academics. But I want what? Performance also important. Performance important. What is that performance says? Look at. Same thing, I'll go to. Carefully watch it. Can I reduce any object memory space? That is the point. Here. I will apply which concept? Inheritance. C2. Actually need to define two functions. Display one and C, for example. I am going to create the same time, one more time here. Why should I waste my time? I can create O2 of what? C2. O2 dot what now? Display 1. O2 dot display 2. I'll get the same answer. 1 minute. Here I am going to introduce, of course, don't worry about it. I'll apply inheritance. I'll remove that code also. Here I am applying inheritance. Save this example. INH example1.py. See this now. Go to this line. Here I am saying that. Come to the point of it. INH example1.py. Got the answer. C1 display 1, C2 display 2. Got my point? Yes. Now here, what is happening? I got 3 objects only, but unnecessarily you wasted your memory space or not? Already it was defined. Again you are defining. It is almost equal to the same only. Today, I'll remove. What I am doing? O2 dot display 1. How the flow is? Display 1 called with respect to O2. O2 is an object of C2. PVM go to C2. Looking for display 1. There or not there? Not there. You will get which error? Attribute error will come. Execute. See that. Attribute error. C2 object has no attribute called what? Display 1. So, how can I get this code? Apply the inheritance. C2 of C1. So easy. Now you see. O2 dot display 1. Display 1 called with respect to O2. O2 is an object of C2. Control goes to C2. Looking for what? Display 1. There or not there? Come on. There or not there? Is there. Virtually it is there. There or not there? There. It is executed. That is same answer is coming. But I am not writing the code. But I am accessing happily. And how much memory space is coming? O2 memory space only. Plus a display 2 memory space only I am getting. But display 1 result is coming. But display 1 memory space is not taking. Getting my point? Execute it. See that answer now. Previous answer. Non-inheritance. Inheritance example. Same answer is coming. See students. Same answer is coming. But what is the difference? Answer is same. Performance is more for this program. What students? Are you having clarity with my explanation? So non-inheritance and inheritance. Non-inheritance says that create an object for every class and call every method. But here it is going to be inheritance is the best. Inheritance uses what concept again? Classes and object compulsory. Inheritance carry the classes and object again. Getting students? Right. Now see here. Now suppose if I say double underscore I am writing. When I write double underscore, what is happening? What is happening? It is not inheriting. I made it hide. Your parent is having ATM card but not giving. He made double underscore ATM. It is there but not giving. Other things are giving. So here, encapsulated here. But now I will remove the encapsulation process. Now what is happening you see? Got it or not? Getting or not? Very good. Next I will go for the same mechanism. See how I am showing now. See students, go to the place. Here you observe it. Do it. 2.2.py. Here I am writing O2 dot display 2. O2 dot display 2. O2 dot display 2. Display 2 called with respect to O2. O2 is an object of C2. C2 is here looking for display 2. Are you following me? Yes. Execute it. Save this code. Save this code. Coming to the point back. Here I am going to state PY. Coming to this. Only display 2 is having. Are you following? Now, see carefully. Here I am writing. Inside of this display 2, I want to call which method? Inherited method. Already method is inherited or not? How do you call it? Self dot display 1. What is self? Current class object only. Display 1. Do you have display 1 here? There or not there? There. How it is there? Virtually it is there. Don't say there or not there. Confusion if you say you are out of order. There or not there? There. You execute it. See the answer now. Same answer is coming. That means I did not define, but I got the answer. Suppose if we remove this line, error. Self.display 1 attribute error will come. Attribute error. Execute it. Attribute error is coming. Is it attribute error or not? Yes. Go to the place. Now I am writing display. Now I am saying here, I am going to say display 1. Calling the base class method from derived class. Getting. Following? Now, let us coming to the point back. Now I am going to introduce. I hope you are understanding how it is getting it. Next, one more. And you will get a doubt. Some doubts will come. What is the doubt? Sir, you see, this is the method display 1. This is a method display 2. Two different names are there. Same name is there. What will happen? Same data member is there. What will happen? I will tell you all these things in detail for you. Okay now? Right. Right now, don't worry. One more example I will say to you students. Program for inheritance only. Please follow me carefully. Now I am writing. Carefully follow. Say INH example 3.py. Class C1. Here def get a of what? Self. What is that now? Self dot a is equal to 10. Today I am concentrating on data members. Another type of class C2. What is this now? Def get b of self. Self dot b is equal to what? 20. Self dot b is equal to 20. Class C2, C3 I will take it. Class C3, get C. And I am saying C is equal to 30. 30. Are you following me? Yes. Getting my point or not? Yes, C3, get C, self, written. Now, C3 contains its own, C2 contains its own. They are separate. But in the class C3, I am taking def operation of what? Self. Try to understand. There I want to do it. Self dot d is equal to, I want to access this A, I want to access this B, I want to access this C. What should I do? What should I do? C2 of what? C1. At various ways I am showing now. Next I am going to say what here? C3 of C2. Which inheritance this is? Multi-level. Spell out? Multi-level. Okay. After this, what is happening? What is happening? Self dot A, self dot B, self dot B. Next is what? Self dot C. Self dot C. Now I am going to write it. Some sum is equal to what I am doing? Sum of, I'll say this A value, I'll say this B value, I'll say this C value, I'll say D value. Simple example. Self dot A, self dot B, self dot C, self dot D. Got it. Now I will come to main program. Now I'll come to main program. Tell me students, what should I say? O3 is equal to what? C3 of. O3 is equal to C3 of. Tell me, what should I do? O3 dot operation. O3 dot what? When you say, what is the content of O3? Please follow me carefully. How do you see the content? O3 dot underscore underscore dictive. Dictive. Please remove. Execute it. There is no hurry at all. Carefully understand. 3.py. Execute. Py. See students. Empty. Empty means nothing is there. Now tell me, what should I do? In O3, you are saying O3 dot operation of. When you say O3 dot operation of, what will happen? It will go to operation, looking for self dot A. Do you have empty object contain self dot A? No. Do you have self dot B in this empty bracket? No. Do you have self dot C in this place? No. Self dot A is a data member which was available in the method. So first you need to call the method or not. To place the value A, first you need to call the method. How do you call it? I am saying that, see, O3 dot, what is that? Get A. Get A. O3 dot get A. When you say O3 dot get A, how it is calling? Get A method called with respect to O3. O3 is an object of C3. Control goes to C3. Looking for what? Get A. Do you have get A here? Yes. Virtuality is there. Why? C1 to C2, C2 to C3. Online students. Is there or not there? There. After print that, you print it. You print it. See, level by level I am showing. See the answer now. Beginning not there. Second time A is there. Okay? Okay. Next. B also I need to take it or not? How do you do that? O3 dot what? Get B off. O3 dot get B off. Get B function called with respect to O3. O3 is an object of C3. Go to C3. Do you have get B here? Yes. Virtually present. You print that once again. Yes. Now how many are there? AB is there now. Beginning empty. Second time A. Third time AB. Next, C also I want. To have the C physical method, you need to call. What I do? O3 dot what? Get C. After that, you see what is happening. What is happening? ABC is available now. Are you getting? Begin. Now you say what? O3 dot what now? Operation you say that O3 data is going to self. In that self dot A, self dot B, self dot C is there. Answer will come. That is the subject. Now you execute. If you want to print here also, you can print it. Of course, answer will come there itself. See, sum is coming. A, B, C, D answer is coming here also. Getting students? Suppose if you call this line in where? Here. What will happen? What will happen? Here it is an empty. Empty does not contain self dot A, self dot B, self dot C. Error. What is that? C3 object has no attribute. A, B, C, D is not there. So, if we want to get the base class data members and intermediate base class data members into bottommost data class, you have to call the base class methods. You have to call the base class methods. So, here this is an output. For your better understanding, I am showing guys. Here I am going to write it. What is this, mom? A colon what? 10. Next, what is the answer next? This is the answer now, comma what? B colon what? 20. Next, what is the next one? 1 minute, mom. 1 minute, students. I say this one. Same thing. I'll come to this place. A comma B comma C. Now I am writing C colon what? 30. Now I am writing here I am saying. What is the answer now? Comma what? D colon D colon, CD, C is also there now? Yeah, C colon. Now I'll write what? D colon what? 60. 60. Are you getting? So level by level, even though get A, get B is not there, I am able to call it. One more way of doing. Students in online, did you understand, students? One more way of doing, students. Carefully follow. I do like this. What? See, I do. Just you call what? Operation. When it goes to operation, what is happening? It goes to operation or not? There you call get A, get B, get C. How do you call it? Self dot what? Get A. Okay, next. Self dot what? Get B. Next one. Self dot what? Get C. That's all. Calling. Derivative class method is calling the base class methods. Happily, you can run the output. See, students, 4.py. 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 Out of that, execute py 4.py. Getting or not? Yes. If you don't call any one of it, if you don't get C, you don't call it. C is an error. C is an error. You have to call the method. Done. This is which inheritance? Multi-level. Multi-level. Please look at one more I am writing. One more I am writing. See carefully. Now I am saying 5.py. C1 you don't write it. C2 you don't write it. C3, okay. C1, C2 are separate. Now you write what? C1 comma what? C2. Which inheritance? Multiple. Multiple. Get C. Done. Get C. Done. Now what I will do now? Operation. Get A, get B, get C. As usual, same to same. Earlier multi-level, now it is multiple. Execute 5.py, 5.py, same answer. 4.py, same answer. Getting. Able to follow? Online students, so comfortable. I hope it is more clear for you. Open the notes. Open the notes. Write a Python program. Write a Python program. Which will implement the following. Which will implement the following. Write a Python program which will implement the following. Write a Python program which will implement the following. Write down. Separate line. Let us assume there exists a university. There exists a university. There exists a university. There exists a university which contains, concentrate on the what you are writing it. There exists a university which contains university name, university name and location. University name and location. University name and location. Continuation. Accept and display. Accept and display. Accept and display. Accept and display. University details. University details. Accept and display. University details. Good. Next line. Let us assume there exists a college. Let us assume there exists a college. Let us assume there exists a college. There exists a college which contains college name and location. College name and location. College name and location. Full stop. Accept and display. Accept and display. accept and display, accept and display college details along with university details, accept and display college details along with university details. Accept and display university details along with college details. College details along with university details. Which inheritance is available there? Single inheritance is there. College is what? Derived class. University is base class. Which inheritance? Single inheritance. Next line. Let us assume there exist. Let us assume there exist a student. Let us assume there exists a student. Let us assume there exists a student which contains student number, comma student name, comma student name, and course, full stop. Accept and display. Accept and display student details along with college and university details. Accept and display student details along with college and, come on, fast, university details. Which inheritance? Multi-level inheritance it is. So let us follow me carefully. Now I am going to use it. Students, follow me carefully. Now I am taking Python here. Observe it. This I will do normal program with modules also. I'll show you modules with the classes, with inheritance. Right. Take care, all of you. What is the mechanism here? University to college. College to what? University. It's called what? Base class. Is called a derived intermediate base class. And next is what? Derived class. Let us talk about it. What is this now? INH. Example. So 6.py. Take care, class, all of you. University. DE of get UNIV details. UNIV details of what? Self. By this time you should be perfect students. Self dot what? Uname is equal to input of enter university name. Okay. Next self dot what? ULOC is equal to input dot university location, right? DE of display university details of what? Self. Print of, I'm just printing the data. University details, I want to print it. Look at, now I'll say like this. Now I'm saying print of university details, \T university details. I'm printing just university details. Carefully follow, guys. Fine, ma. I'll print it. What is this now? I say here university name. I'm writing dot format of uname. Next I'll write it university location. I'm writing ULOC. That is about what class? University class. This is perfect. One person has defined that. Online students, carefully follow. Ma? 100%. Correct. Self dot. Here I need to write what? Self dot. Good. Self dot I need to write it. Okay, guys? Well, now I will write it. Class college. Class college I will take it. In the college class, I'll get these things. I'll copy the students and then to come to do the fast thing. I will take my own function here. What is this now, ma? I say college details of cell, C name students, CLOC I am taking. Enter what name? College name. No. So I am seeing that college name and the next is called what? College location. Okay. Go to that college details also I want to take it. College details I will take it. Here I am writing college details. So I'm taking that. Here I am writing, college name and a college location I am taking. Display college details. Display what? College details. So I will take it college details. Okay. Self dot what? C name. And self dot what? CLOC. Done. And moreover, college require university features or not? I will write what? UNIVE, I will write it. Which inheritance? Single inheritance. Good. I'll go to the next. What is this? Student. Inside of it, I will get the details. Of course, I'll change my details. Get what details? Student details. I say yes name. Yes name. What name? Student name. Student course. Next I will write it. Student course. Student course I will take it. So course I am taking. CRS I will take it. CRS. Next self dot what? SNO. Int of what? Input of. Enter. Student number. Enter what? Student number. Done. Enter student number. Student name. CRS. Similarly, coming to what? Display. Which details? STUD details. I will print student details. Call student name I will write it. Student name I will write. Student course I will write it. Student number also I will print it. Student course I will print it. So go to this now. Yes name. What is this now? CRS. Moreover, I will write next student number also. Student number. What is this now? SNO. SNO I will write it. So student number I will write it. Getting students? Well. Huh? So along with the university details and everything I want, I will write what? College. Multi-level. Well. Go to the program now. What I'll do? Main program. If I run my program now, no output will come. Main program. Nothing will come. Not executing at all. See students. INH example 6.py. You save it. Execute it. Py. See students. No output. Without class, without object, no use. You have to compulsory create what? Object. So, come on. Which object I'll create? Student object I'll create. SO is equal to what? Student of. What is the content of SO? Empty. Chupichan already. Empty. Now I have to call what function? Yes. UC. SO dot. SO dot. I need not to show you. I hope so. SO dot D underscore DOC. Dict off. You already seen now? Right. Done. After that, you are getting these details. SO dot get college details. College details. College details is there in the student. Yes, virtuality is there. SO dot what? Get university details. It is also there virtually. I will print. I will print the data. How do you print the data? First, I'll print university details. On the top of our memo, university details will be there. I'll print it. SO dot display university details. SO dot display college details. SO dot what? Display. STUD details. Done. Execute it now. Execute it. Done. See students. Enter the student number 100. So something I'll write it now. Some student name I will write it. Something like Naveen. Naveen. Student course is called BTech. BTech. I'm writing here BTech CSC. CSC. College name CBIT, for example. Something like this I am writing Kandipet. Now I am writing University, Usmania University. So I am writing like this. Location is called Hyderabad. Tarnaka, Hyderabad. So Tarnaka, Hyderabad. See that? What is happening? Display UNIV details. So UNIV details. Display UNIV. One V is missing. Python is very dangerous. So output is coming. University details, college details, details. So next is called what? Student number is called 1000. Some student name I will write it. Right? DOS. Student course, BTech, CST, without knowledge. If any student name is there on this name, don't feel students. I'll check it out if anybody is there. Oh, nobody is there. So, college name, ABC College, ABC location, ABC location, ABC University. So HYD. So like that. So this is like this. Because any university if we go, you know what is happening. What is happening? Memo they will give. In the memo, what is there, you know. And before that, what is there in the brain, you need to know. Pass only. But what is there in the brain, we should apply it. Any of students, you have done it. Understand? This part, I'll show through modules. Shall I show through modules? Well, online students, follow me. This class I'll write separate. Separate class I am writing. What is my class name? University. I will write it. University. Dot what? Py. What is this now? File name and module name. So, university dot py. See, done. Next, I will take one more. What is the next one? So, here. I'll take it. I'll take this part. College, I will take it. College. This is a separate program I am taking. Separate program I will take it. Take care, students. I will take up new program, new, others. See here. I wrote it. Here I am writing college. College dot what? Py. Module name, file name and what? Module name. File and module name. Class also same. No problem now? No problem. College. But university you are taking. But I should write what? From university, import what? UNIV. 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 You need to take it. College.py. College.py. Done. Next I will take it. Next I will take it. Student. Student is called what? Separate again. I'll take it file, new, others. say Python. Now I am pasting. Here I will write it. What is this? Now I am writing. Student dot what? Py. File name. And what next? Module name. Save it. In this place, you know, students, what to import. What to import? From college, import college. From college, import college. Done. Save this now. Student.py. Done. Now I will write one more main program. I will write it. Main program. See the importance. University, college, student.py. Create which object? SO is equal to what? Student of. What is this now? From student, import student. SO dot. You can happily write all those functions. Where? Whatever you have written now, same thing you can write here also. Happily you can write. Save it. I'll do some changes. What happens? Saved up. Go to the place. Execute. PY. See that number now. I'll go to this place. 100. Like this data I am entering. Output is coming. Well, but students in online. See students, but I don't want to write this much of great story here. What I do? SO.get student. From here I will control everything. Go to where I am going? Student. From this place, after calling the student data, yes, self dot. Get college details. Self dot what again? Get university details. Well, okay. When you say this part, when you say this get data, it is calling. Well, if you want, I will call this display student details from this place. SO dot what? Display. Sir, can't I call from there itself? You can call there itself. You can call here. Self dot what? You call that function. Which function? That function itself you call. But I want to have some separation. Okay. When you say this display, it will come to this place. Here, before student display, college display. Self dot display college display college details. That before self dot display university details. Are you following me? Right. Done. Execute. Save this code, students. Observe it. Done it. You say this example. See this now. See that number. Say the date, same details. BTech. Say something like OUCET. Something like Tarnaka. Same university campus. Usmania University. So Hyderabad, Tarnaka. You are getting the same details now. Are you getting? Like this also. So here what is there? Modules are there. Inheritance is there. Reusability in different places. This program I will keep it into control panel. Python path I can write it. I can access everywhere else. That is also can be done. And this much great concept is there in inheritance. So student is not writing anything else. Not writing college, not writing university. Just only these two are written. But extra how many functions are coming? 4 functions are coming. Is it not taking less time here? Yes. So tomorrow Monday class when I come back, I'll stop the class today. Monday class when I come back, inheritance not over. To the inheritance, I'll add polymorphism also. Monday class I will add polymorphism to the inheritance. Inheritance and polymorphism comparison. You will vote for polymorphism. Polymorphism uses what? Inheritance. Along with that, one method overriding concept is also coming. That also we will discuss. So Monday class, don't miss it. Polymorphism will enter into that. Okay, now? So I'll stop the class. Method overriding, polymorphism, Monday class I'll introduce. Don't miss it. Thank you. All the best. Online students, you can hold on. Aniket, I will upload. I'm remembering. You can hold on. I'll talk to you. Thank you.